So hopefully you are here to listen to a session on roles and responsibilities of the Azure Data Engineer. I'm going to cover what the session is about right at the beginning. If it's not what you were expecting and there was something else on the schedule that you thought was equally interesting, please obey the rule of 2 feet. If you find something more interesting to go to, I will not be offended. It's your time. You're here to learn. Do what you need to do. Just a couple housekeeping slides. You're going to see these about 100 times this week, but I get to do them first, so hooray. Please do silence your cell phones. We just don't need the additional interruptions. And remember, you are here under PASS, and PASS is a big community. PASS offers you a lot. Learning and connection does not stop at the end of this week. I've been involved in the PASS community for well over a decade now, and it is how I have made friendships. It is how I have found out about some of my jobs. It is how I am here standing on stage talking to you today. Who here attends a local or regional PASS user group on SQL or data? That's fantastic. I love that. Me too. If you're not attending one, please try to find one in your area. If there isn't one in your area, consider starting one or attend one of the many PASS virtual chapter presentations that are offered on a monthly basis. All right, I said there'd be an exam at the end of this. It's called the session evaluation. This is my first time giving this session at a big conference. I've given it to a couple user groups in SQL Saturdays, but I want your feedback on how to make this better. So you can either go to passsummit.com and fill out a quick eval. You can do it through the guidebook app. Just search for this session and give me an eval. I think that's the easiest one. Or follow your QR code, which I think is on this just outside the door. And for those of you that don't know me, hi, I'm Jess Borland. I am a software engineer at Microsoft. I work in our commercial software engineering division. We're pretty tightly coupled with the engineering groups that write code for our Azure services. But what we do is we go on-site with our customers and code with them to help them make Azure solutions to solve their business problems. I live in the Azure world. I've been doing this now for, going on, 5-6 years. It's been my goal to do this full time, and here I am. Azure is definitely rapidly changing, and I get to see that every single day and every single week. My contact information is here. I love getting questions. I would like questions during this session if you have them. I will take questions afterwards. If you think of something later this week, please email me, send me a message on Twitter, or you can also visit my blog. I haven't blogged in the last couple of years. I find it hard to blog about Azure topics because things change so rapidly, which is why I give more presentations about it, because those are a little bit more live and up to date, and I tweet a lot too. So this session is the first in one of our learning pathways here at Summit this year, kind of a prescriptive set of sessions that are going to cover a topic from end to end. My session's going to be a pretty high-level overview of what is data engineering, what do the exams look like, what technologies will you use, and later this week we're going to have 3 other sessions that cover it more deeply. So Azure Storage Options for Analytics will be this afternoon. And Azure Data Engineer's ETL Toolkit is tomorrow, and Data Modeling Trends is on Friday. If you find what I talk about interesting today, please consider going to Dustin and Simon and Ike's sessions to learn more and dig more deeply into this. We also do have a data engineer study group happening in one of the rooms. I saw the sign for it just by the top of the escalators this morning. Room 204, thank you. So if you're really interested in digging deep into it, getting some more hands-on experience, asking more questions, you can continue to do that this week as well. So what am I going to be talking about today? I'm going to talk about how the rise of data science, predictive analytics, being able to say, I have this information, and rather than being reactive with it, I want to be proactive with it. Data science has led to the rise of the data engineer. Here's the thing, those data scientists that are writing algorithms and doing tests on it are like the final mile of a marathon. I'm a runner, for those of you that don't know, so lots of those kinds of stories. The other 90% of the work comes well before algorithms are written and tests are run. Data has to be discovered, data has to be classified, it has to be ingested, it has to be extracted and transformed and loaded. There's a lot of work that goes into it, and that's rolled up into a role we're starting to call data engineer. Because of that, Microsoft has come out with a certification called the Azure Data Engineer Associate. So we're going to talk about what data engineering is at a high level, right? What problems will a data engineer solve in a business? Skills that you'll need to be a successful data engineer. Tools, from a very high level, more categories of tools than anything. And then specifically, I'll dig a little bit into Microsoft's data engineer certification path and the next steps that you can take if this sounds interesting to you. So let's talk a little bit about why you should be interested in data engineering. And I'm going to say again, behind every good data scientist is probably a team of data engineers. It's a complex process and methodology to get to being able to write an algorithm. Again, data has to be found, it has to be cleansed, it has to be modeled. That takes a team of people. This is interesting and challenging work. For those of you that have thrived in the past on programming, scripting, and are code-driven, this is a great path that offers a ton of work in that regard. And it's also one of the highest paid jobs besides data scientist in the industry currently. I did a bunch of research on data engineer jobs. I picked closest city to me, Milwaukee, Wisconsin. I did not choose something like Seattle or San Francisco, where everyone makes a bunch of money but has to spend it all on housing. And you know, in average, around different data engineer jobs, different companies, average salary is about $100,000, right? Data engineering is a popular and well-paying job, if that's something that attracts you. So now we're going to start talking about problems a data engineer solves. But let me just take a step back and say that data engineering is a discipline, right? It's something that encompasses those three pillars of people and process and technology. So I'm going to talk at a very broad level, a very high level about this process of data engineering and the skills you need for it. When it comes to the Microsoft Azure certification, we really dig most deeply into the technology portion of it and specific services and platforms in Azure that you'll use. But I want you to understand from a really high level what part data engineering plays in the whole scope of a project. So Monica Rogati built this beautiful pyramid that I found one day, the data science hierarchy of needs. Data science, for many companies, is sort of the holy grail of using their data, right? And I have been saying this for years, and I will continue to say it. These days, a company's business is their data. The most valuable asset most companies have is their data. And we use it in many different forms. A lot of companies are using it in a reactive method, right? Using it to find out what happened in the past. How much did we make in sales last year? What percentage of items failed QA in the last week? How many people have ridden the train in the last hour. What companies are now trying to achieve with data through the data science process is being proactive and being predictive with their data rather than reactive. How do we do that? We gather the data, right? So we have all of this data coming in from all of these sources. It can be applications, it can be sensors, it can be websites. Everything in the world is generating data these days. We collect it. Then we have to move it into a central location and store it because we want to perform analysis on it. Then we need to start exploring it. What does the data look like? What do we want it to look like? How can we cleanse it? How can we make a common data model? After that, then we can start doing some analysis on it, some analytics on it. Data scientists can start building some models. They can start doing some training. And in the end, we can even get up to going beyond machine learning to artificial intelligence and deep learning. But to get to be one of those people, those data scientists that are at the top of the hierarchy and writing those models is years and years of school. Most data scientists I know have PhDs. And again, 90% of the work is already done by the time that they get there. The data engineer is the team and the people that work on the process of moving and storing the data and exploring and transforming it. That is the space in this data science hierarchy of needs where the data engineer lives and shines. They may go up a little bit and they may go down a little bit, but this is truly where we want to focus on that. So the way that I look at it, we are going to cover 5 main pillars in data engineering. We're going to talk about how the data engineer influences the infrastructure of a solution or a specific project. We'll talk about how they help with data ingestion, build data pipelines, perform ETL and ELT, which is kind of a new phrase that's going around, and talk about data modeling. So what do each of these mean? Well, infrastructure is the most basic part of these solutions. You're going to have data, and it needs to be stored somewhere. You need to have compute and memory to be able to process this and build it. Data engineers can help in this regard. They're the ones that are going to be designing and building these solutions. So when it comes to something like Azure or another cloud service provider, a data engineer needs to know, what compute options do I have? Am I going to be doing something like infrastructure as a service, or am I going to be using platform as a service tools, right? Does this cloud provider already have something written that can do this for me? So you need to be aware of what tools exist and what their best use cases are. A data engineer is also going to have to be able to build distributed systems. Oftentimes with data science and data engineering, we are working with big data, right? We're going to be dealing with vast quantities of data in structured and unstructured formats. We build distributed systems to handle all of that. What is a distributed system? It is simply being able to scale out the work between multiple computers. For those of you that come from like a SQL Server background, which I assume is a few of you, think of it as kind of like an availability group, right? You have multiple servers that can handle incoming write requests, incoming read requests. You can spread out the work. For data engineering, we often build distributed systems like that, clusters of computers. Oftentimes, this is Hadoop's distributed file system, or HDFS. You're going to see HDFS quite a few times on these slides. It's a common tool with big data. So that's the first pillar of data engineers. They build and code infrastructure. The second tool that data engineers have, or a second process that they're good at, is data ingestion. Again, companies have data, and it's all over. I mean, how many of you have just one database server? No, everyone has database servers, and they're multiple different types. Oracle, SQL Server, you might have Postgres. You probably have some Excel spreadsheets that contain important business data, JSON files, image files, a lot of different types of data. Data engineers are able to identify disparate data sources that cover all of these different types of data and know how to bring them into their system that they're building, right? So we've built this infrastructure, we have our storage, we have our compute, we have our distributed system. Now we know how to find our data and bring it into this system. Then data engineers start building data pipelines. Pipelines are going to be coded, programmed, scripted ways to bring the data into a common data store. Because in the end, the data scientists are looking to report off of one pool of data, do analysis off of one data warehouse, one HDFS pool. Pipelines are sort of synonymous with DevOps. I've gotten really good at DevOps in the last year, and by really good, I mean that yesterday I went into Visual Studio Code and I cloned a repo all on my own without having to ask anyone for help in under 5 minutes, and I was extremely proud of myself. I can, in Azure DevOps, build a YAML pipeline now. So this is something that as I've gotten closer to data engineering, I've realized that DevOps is quite a part of that. So if that's something that interests you, if you have that programming background, or if you want to get involved in that, this is very synonymous with data engineering. The next skill that a data engineer will perform is knowing the difference between ETL and ELT and being able to perform both of them. The common pattern over many years has been extract, transform, and load. We have our source data. We use a tool, maybe something like SSIS or Azure Data Factory, to then transform that data. We cleanse it. We make sure we remove unnecessary columns. We merge data sets together. We have it in a predefined format that we're going to, in the end, go ahead and load it into our database, data warehouse, or other data source. ETL processes can be thought of, the words that I like to use are continuous and ongoing and well-defined, because this is a process that happens on a regular basis. But the problem, the downside, the trade-off, shall we say, is that ETL can be very rigid. The same data comes in, and a set of data comes in, and it comes out exactly the same way every time, which means that the number of questions that a data scientist or an analyst can ask of it are limited because it's predefined. So now what's becoming more popular, particularly when we deal with large amounts of unstructured data, large amounts of big data, is the extract, load, and transform, or ELT pattern. This is a more common pattern when you have a large amount of data and your analysts or your data scientists say, I want to be able to ask free-form questions of it. Or I don't know exactly what I will glean from this. So how about you just take all of the data that I give you from all of these disparate data sources we've identified, build a pipeline to dump it into a data source, a data lake probably. Just make sure it's cleansed, and then I'll do the work. I will transform it. I will use tools to query it. Another reason that we tend to do ELT with data engineering and big data scenarios is also that when you have extract, transform, and load, again, predefined process, run on a regular basis, the more data that you have, the longer that takes. Who has ever had an SSIS package that 6 months ago ran fine, but now is starting to take more and more time overnight? I see heads nodding. And that's a common problem with ETL. With ELT, the data is just dumped into this data lake or data store, and it doesn't have, so if you have varying amounts of data coming in every night or different amounts of data that you have to deal with in the middle of the month versus the end of the month, the amount of time that it takes to do the loading of that is pretty much, it doesn't matter as much because you don't have to do those transformations on the data. So that is one of the reasons to pick the ELT pattern. And last but not least, another problem that a data engineer will solve is data modeling. Again, in both of those patterns, ELT and ETL, we deal with the loading. We're loading the data into a data warehouse. We're loading it into a data lake that is going to have to be presented in some format. If it is a data warehouse, we're going to have to make decisions like, are we using, the Kimball methodology or the other one? Are we doing star schemas? Are we doing normalized or denormalized? So a background in data modeling, a familiarity with data modeling, an interest in it is a skill that a data engineer needs and a problem that they can solve. Oh, we have a question.
So before we get to this level, like you said, a traditional way of doing things was ETL, right? So if I'm going to dump data into a lake, I need to know the destination, right? What's the data type? Like the traditional way, I know I'm moving an Oracle or Excel into SQL Server, vice versa. So I can tell what data types I'm going to change the data into. So with this ELT process, so if I'm going to just dump data, what do I dump it? And what's the data type conversion?
Great question. So going back to the ELT pattern, transitioning into the data modeling for that loading section, how do you know how the data looks in that data model? Is that what you're asking? What do you do about data types? How do you, in that load section? You're still going to have to work with you're going to have to define that source, that destination ahead of time. You're going to have to say, we're going to put this in a SQL data warehouse, or we're going to have to put this in Snowflake, or we're going to use a data lake, or so you know that ahead of time, and then based on that, each of those tools and data stores has different data types, different table types, that sort of thing. So you do still need to define that a little bit ahead of time. Question?
So the decision about the schema, the star schema, or whatever method you're using, is that done in the lake, or is that done beforehand when you load it?
Great question. So the decision about star schema, Snowflake, is that done before you load it or after you load it? That is a great question, which will take far longer than I have to answer, which is why we have a session just on data modeling on Friday. And I would suggest you go into that.
Can I ask you just something quickly?
Yes.
More of a virtual thing, or is it actually loaded that way?
Is it a virtual thing, or is it the way that the data is loaded?
You have a star schema that doesn't really exist, but the lake, because it can handle these different data types, presents this virtual feeling like it is, but it really isn't.
I don't have a great answer to that question in a short amount of time. So we can talk after, though, a little bit. Okay, thank you. So those are, again, the problems that data engineers solve at a very high level. So next I want to, so those are my 5 pillars. Again, the infrastructure, the data ingestion, the pipelines, the ETL, ELT, and then data modeling. So what skills in general, again, without getting too deep into the weeds of, again, that Azure certification and specific things, what skills do I think a data engineer needs to be successful? What do I see at a high level? There's 4 main things that I think we should have to be successful. And first is an understanding of DevOps. Data engineering is, again, very code-driven. And here's the thing, and this is what I'm especially noticing in this new role that I have at Microsoft. Software engineers who deal with application code are traditionally very well versed in DevOps. Almost every application has source control, continuous integration, continuous delivery. Applications talk to databases. But database administrators and database developers think, I don't know how to put my database in source control because the data is always changing, and how do I get back to it, and what if something goes wrong? The subject of DevOps for databases is another session entirely. Maybe I'll be talking about that next year if you want to come back for that. But it behooves us, even as data professionals that want to be data engineers, to start learning software engineering fundamentals, which are DevOps. So and the basics are learning source control, right? How do I take a script I've written, check it into a common data repository, and then write another script a week later to change something, maybe make a modification to a stored procedure or a view, check it into that common code repository, and over again. And then if I ever need to roll back, I know exactly what state that was in at that point in time. That's all source control is. Learning continuous integration is another step in the DevOps process. Continuous integration really involves testing that, like, the stored procedure will execute every time. It just means testing that when I run this create table script, something automatically runs it to make sure that the syntax is correct, right? Just checking to make sure that your code's valid, essentially. And then continuous deployment. CD is the great level where you have all of this code that you've checked into source control and all of these objects you've built and you've tested to make sure that they're valid. And then you get to automatically deploy them. Why do we care about DevOps? DevOps definitely frees up our life to be much smoother and much better once it's fully integrated. I mean, I think about the way that I have done manual releases, especially for data objects over years, right? Let's roll this out on a Friday night at 10 p.m. when no one is, no one's going to be in the system. And you're the administrator that has to go in at 10 p.m. And something goes wrong inevitably because someone didn't do any testing of their script, and suddenly you're working till 6 in the morning on Saturday. With a consistent, well thought out, well orchestrated DevOps process, you can roll that change out at 10 a.m. on a Wednesday because you have defined your process, and it can take minutes instead of hours. That's why we want to get to DevOps. Better quality of life, I'll put it that way. Another thing that you'll want is familiarity with scripting languages. I'll talk about a few languages and where I feel you should be investing your time in the next couple of years. But I want you to be familiar with scripting because as a data engineer, you're going to be building infrastructure as code. So remember how I talked about infrastructure and how you need to be building these distributed systems? You don't want to go in and manually build a virtual machine every time. You don't want to go into the Azure portal and spin up a Databricks cluster. You want to have a script that you can just run. That's what you want to learn. You can build all of that and put it into DevOps. And then again, those pipelines, right? The scripts that you have to build things, the ETL and ELT, that is all done via scripting. Scripting is time-saving, right? It takes much less time to, if you're doing everything via the GUI or a UI all the time, right? It takes 5 minutes the first time, takes 5 minutes the second time, takes 5 minutes the third time, takes 7 minutes the fourth time. Writing a script, take 10 minutes the first time, and then 2 seconds, and then 2 seconds, and then 2 seconds, right? So it's time saving. You get consistent results. You can repeat it over and over again. And especially if you're using source control and CI/CD, it's verifiable. You can say, what did I run last Friday at 2 p.m. that made that change? So scripting languages are going to be a great asset to have as a data engineer. You'll also want to be familiar with and love automation. Who here loves automation in their current job? Great, you're already well on the path to becoming a data engineer. These are things, again, we're going to be taking those disparate data sources, building those data pipelines, ingesting them into a data store. We don't want to have to rebuild that every time. We do it the first time, refine it the second time, and automate it from that point forward. And last but not least, an ability to understand not just the how of scaling systems, but the why and the when. This is especially important when we're dealing with cloud systems, where we are paying for every gigabyte of data we use and every minute of compute that we process. So a data engineer is going to know the difference between vertical scaling, where we say, we have this system, we need to add more resources specifically to this system, this database, this virtual machine, this server, and when to horizontally scale out and say, rather than making one big server, I need to build out my distributed system. So see, these things are all kind of coming together. That infrastructure piece is closely tied to this knowledge of and ability to scale systems. And again, scaling is especially important for a few reasons, like no one has less data than they did a year ago, right? Does your company have less data than it did a year ago? Not a chance. No company has ever said to me, I have these 6 data sources, but maybe only 3 will help me make my decision. No, they say, can we find like an industry data set to add into this? And we found this other interesting piece of data from within the company, and we have this, right? They want more and more and more. So we need to be able to quickly and efficiently scale up when they decide that they want to add more data into the mix. And we just don't know. We cannot predict when something will all of a sudden take off, right? When suddenly a new product or service is suddenly incredibly important. And another thing that I didn't put on this slide but is incredibly important is most businesses have peaks and valleys in activity, right? One of my biggest customers in the past, one of my biggest industries has been retail. Retail has a very specific period with which they are busy. It's starting right about a week ago, right? We think about typical trends from November, December being very busy. January has a lot of returns and analysis and all that. And then it dives down, right? And then the next year it goes back up. Especially when we're in cloud systems, we don't necessarily want to be paying for the resources we need to have on Black Friday in November on August 17th, which is a Wednesday, and nobody really needs our products. So scaling, understanding, again, not just the how, but the when and the why is an important skill that you can take into that. So now let me talk a little bit more about specific tools that I think you should learn. All right. Again, for these things, for infrastructure as a code, these are some of the tools you might start seeing out there. Again, especially depending on which, are you using Microsoft-specific tools or are you using more open source? Are you using Azure? Are you in AWS? Are you in Google Cloud? But infrastructure as code is what tool do we use to define that distributed system and then build it? In Azure, we use Resource Manager templates, JSON. AWS has CloudFormation, and Google has Deployment Manager templates. But there are also third-party tools that will help us build this infrastructure as code and orchestrate it out. One of the most popular, and the one that I'm hearing a lot more internal Microsoft people say, and a lot of my software engineers at customers, is Terraform from HashiCorp. That's becoming, offers a lot more flexibility and advantages over something like Resource Manager templates, and it works with all of the different cloud systems and on-prem systems. So I bet that you're going to hear more about Terraform in the coming years. And tools we've had for years are things like Chef and Puppet, which allow us to write these recipes and deploy them out. So those are some tools you might hear at a very high level. When we're working with pipeline as code, remember I said you want to build these pipelines, part of the DevOps process. Common tools for DevOps. Again, from a Microsoft perspective, we have Azure DevOps. I actually really like it. It's made my life much easier. But it's not the only tool. Another very common DevOps tool is Jenkins for building pipelines. A tool, and I have not used Travis CI, but I know that that's another common one, and even TeamCity. So if you see these words, see these names, that's what they mean. Languages. Remember how I said that knowing programming languages, knowing scripting languages, for those of you that have programming backgrounds, data engineering is going to be really fulfilling for you? These are where I suggest you either have some background or learn some. So first off, structured query language. And note that I don't say T-SQL, which is Microsoft's implementation. Just structured query language is still the language of data. And data engineering and data science are based on data. All these different tools that I'm going to talk about in terms of data stores, right? Sure, SQL database and SQL data warehouse use SQL. Cosmos DB still uses SQL. Stream Analytics uses a version of SQL. Almost all talking to different data sources can be done with structured query language. Then there's the language of the data scientists, Python and R. My goal, my learning, besides DevOps right now, I'm investing in Python, and I think all of you should be investing in Python. Python is a data science and mathematics-driven language, but it's used in a huge variety of things. For example, one of the projects I'm working on right now in my day job is to help build one of the SQL 2019 big data clusters to deploy into Azure using AKS, and our deployment scripts are written in Python. And when you go to work with something, if you have any familiarity with Azure Databricks and Spark and those sorts of tools, can include Python and probably will. There's a ton of great resources out there. I have some links at the end on how to learn Python. I think that if you're going to learn a new language in the next year or two, that would be a wise investment for you. R is another data science language, a little bit more mathematically based. If you have familiarity with JavaScript or another just object-oriented programming language, it can come in handy, as that's how some tools and processes are written. And speaking again for Microsoft and Azure, management of things, building of things, PowerShell. Who loves PowerShell? Yes, that's much more hands than I used to get when I talked about it 5 years ago. So good. PowerShell, and then the Common Language Interface, or CLI. If you're going to be using our Azure tools and you want to write things as code, you're going to be writing it in PowerShell. All right. Got to keep going. So, questions about that stuff? Yes?
When you speak of pipelines as code, and in particularly tuned to Azure DevOps, that's one of the challenges that I faced over the past probably 2 years, where I want to source control my pipelines.
Mm-hmm.
But I find that all I can do is source control the YAML.
Mm-hmm.
There are still these things as variable groups and task groups that are defined outside of the YAML. Have you found a solution for also being able to codify and source control that?
All right. Let me try to summarize for everyone. When you use Azure DevOps, and you build pipelines in Azure DevOps, it builds it in a file that's written in YAML, or yet another markup language. That YAML file can be put into source control. It can be checked in, and that's what you want to do. That's pipeline as a code. But there are certain aspects of the pipeline, like variables, that aren't necessarily in the YAML itself. So is there a good way to make all of that packaged up and put into source control as the full pipeline? And my answer is, unfortunately, no, I don't have a better answer for that yet either. That's one of the things I've been struggling with over the last, I'd say 3 months in particular, with a project that I'm starting to build. Thankfully, the Azure DevOps team continues to improve that. So hopefully that comes along, but I don't have a great answer. But you're not alone. That's all right. Yes?
So for the Python, there are many libraries available, right? That SQL Server, does Microsoft make sure that those libraries are protected, make sure they're secure, how malicious codes are there?
Can you give me an example of one of the libraries?
Python, right?
Oh, yes.
Right? So we use a method package to make sure that it's broken out and secure in our environment. It's something that Microsoft does that make sure the libraries are safe enough to use.
Okay, so the question was, there are, especially with Python, a lot of different libraries and packages that you can use. When you do them, say, on-prem or in an IaaS environment, you can make sure that they are safe and secure. Is Microsoft running the same sorts of security and checks in our PaaS-hosted services, like an example of Databricks? For example, yes, we do a bunch of security and compliance checks. If you're ever interested, just do an internet search for, I think it's the Azure Compliance Portal. We have a full list of all of the different things all of the different certifications we meet, all of the different checks and tests and things that we do. So you can investigate that a little bit more further there. You're welcome. Yes?
You mentioned infrastructure as code.
Yes.
In Azure, there's a multiple spin resource using ARM template, using PowerShell or CLI. Do you have any insight what's the advantages one over the other?
Okay, so when we talk about infrastructure as code, and especially related to building things in Azure, you have choices. The ARM templates, PowerShell, CLI, do I have a preference or what are the pros and cons? That's a long topic that I don't necessarily have time for, but I don't want to get distracted and go into that rabbit hole. I would say that.
Jess, can I answer that just quickly?
Yes.
I think it depends on your audience, and so you end up doing a lot of all three, because it depends on what the user needs to do. So I know that's not a great question.
We can say the usual, typical. It does depend. It depends on what systems you're hooking into. It depends on what developers you're working with. We give you choices because we realize there are multiple situations for it. Yes. All right. So let's talk briefly then about Microsoft's specific data engineer certification path. The Microsoft Azure Data Engineer Associate consists of taking 2 exams, the DP 200 and the DP 201. Exam DP 200 is on implementing an Azure data solution. So this is things where you might be posed questions like, we've decided that we're going to build Azure Data Lake Store Gen 2. We need to secure it. How do you do that? Or we've decided to implement a Cosmos DB Cosmos DB SQL API. How do we create our partitioning strategy for this particular one? So the DP 200 is based very much on the implementation of the data storage, data processing, and data solutions. At a slightly higher level then, DP 201 is about designing the solutions. So the theme of those types of questions and activities and case studies is more like, you have this business problem to solve. These are the different Azure, storage solutions. Like, you need to choose where to set this data type. You have blob storage. You have Cosmos DB. You have Azure Data Lake. Which one is best to meet these business requirements? Or, you need to hook these three things together. Which tools in Azure will allow you to hook all of those together and perform this task end to end? So that's kind of the difference between the two. The 200 is a lot of, we already know what we're going to do, and this is how we do it. The 201 is a lot of, we're going to give you a scenario. You need to know which tools solve which problems. But in the end, there's a question. Yes?
I didn't really mean to cut you off.
No.
I've been watching that chart for the data engineer, Azure Data Engineer, and there's blocks with little dotted lines. So there's like an Azure Platform 100 level certification. Then there's the data engineer, and on the right-hand side, there's the architect, the Azure architect. Is that intended to, well, my question really is twofold. Is the data engineer associate a prerequisite for the solution architect? And is the 100 level certification for the Azure offerings, whatever they named it, I don't remember, is that a prerequisite for the data engineer associate? And I asked that because those little dotted lines confuse me.
So the question is around the different Azure certifications that are available. There's the 100 level, the 200 level, the 300 level. Are certain ones prerequisites for others? Off the top of my head, I don't know. That's a bit of homework I did not do in the last couple of weeks. My experience, yes, Neil? Okay, so Neil teaches on this subject, and he'll be able to answer your question after the end of the session if you'd like to get connected. Yes, thank you, Neil. See, one of the things I love about Past Summit in our community is there is someone in the room that knows the answer. So let's talk a little bit about, yes?
Do you have to take those two in a specific order?
Do you have to take those exams in a specific order? No, you do not. You don't have to pass one to take the other either.
Do you have a recommendation on which one you should take first?
Do I have a recommendation on which to do first? My personal experience, but this was back when they were still in beta, and they have been changed a little bit since then. I took the 200 first, and I failed it miserably. And then a week later, I took the 201, and I passed it. And then about a month later, I took the 200 again, and I passed it. So for me, personally, with my experiences, the 201 was easier for me. But again, everyone has a different background. Everyone has a different skill set. The good news is that out on our pages, so there are, when you go to download the slides off the Past Summit website, there are links in the notes section of these slides with links to the certifications, links to some study materials and prep. So look through them and just decide what sounds easier based on your experience and your studying. All right. So the technologies that we've covered. So now I'm going to remember I said, data engineering is a discipline. There are pillars of people and process and technology. And I wanted to talk about the process and the people skill, the skills that a person would need. Now we're going to delve into the specific technologies that the Microsoft Azure certification covers. We talk about databases. Imagine that in a data engineering certification. So some main categories of databases in Azure. Cosmos DB. Cosmos DB is our NoSQL database. It has multiple APIs that allow you to store data in multiple formats, like the SQL API, formerly known as Document DB, which stores JSON data. You can do key value store data. And you can even do a graph API. Cosmos DB lends itself better to unstructured, again, NoSQL data. For relational data, we have SQL database, right? And you can do a variety of different flavors of that: single databases, elastic pools, managed instances. We now have hyperscale and serverless. In addition to SQL database, as a relational database, we also do offer MySQL and PostgreSQL for as PaaS offerings. And you might see a little bit about all of those in that exam. And for the data warehousing from a more structured format, we have SQL Data Warehouse. SQL Data Warehouse is our MPP platform, multi-parallel processing. And that means that when the data is stored, it's sharded out across a distributed system. See? I'm using all these words so that you become familiar with them. And SQL Data Warehouse is where we store our, the aggregated data, star schema, snowflake schema, that sort of thing. So you're going to need to become familiar with all of these things. Question mark?
Isn't that where the new Synapse would fit?
I knew this was going to come up. The question is, isn't this something like the new Azure Synapse Analytics platform? Doesn't that come into SQL Data Warehouse? Yes, the Azure Synapse Analytics platform that was announced earlier this week is an introduction of new features into SQL Data Warehouse that is part of that platform. I don't believe the exam has, the core concepts of it are going to change just based on that announcement, because the underlying structure of SQL Data Warehouse and the problems it solves are still the same. All right, so databases, that's one area that you'll become familiar with.
So to query Cosmo, because I look into Mongo,
Mm-hmm.
I realize I need to know some JavaScript or Python, as you said earlier. Is that how these are also manipulated, the Cosmo? Like, what tool do you use to manipulate Cosmos DB?
What tool do you use to load the data into Cosmos DB? That's a question that's outside the scope of this session, but I can talk to you afterwards. You can grab my card, and we can discuss that in person or via email. Yeah. Or you can come to Jim's session later today, and he's going to answer that question for you. You might want to get his information afterwards. Great. All right. So besides just a database, right, structured, formatted very specifically, we have other data stores in Azure that you'll also need to be familiar with. Blob storage, just Azure storage, is our most basic. This is going to store any sort of data, structured or unstructured, flat files, media files. Blob storage has been around a long time. It's used for a lot of different things. It's very familiar to people that use Azure. But we also have data lake storage. Data lake storage builds on Azure Blob storage, but offers some additional metadata operations. There's a word I'm looking for. It stores the data in a blank way, hierarchical way. That's the word I'm looking for. And it just offers additional options for big data, unstructured data. Again, one of our options for data lake storage, Hadoop HDFS. And it offers the ability to store significant amounts of data, up to petabytes. So you'll need to become familiar with these non-database data stores as well. You'll need to be asked questions about data transformation tools within Azure, and hint, that's Azure Data Factory. So Azure Data Factory is a tool to implement ETL, or ELT, at scale. Azure Data Factory has over 80 connectors to tap into different data sources. So these are everything from SQL and Oracle databases to flat files to other data stores. And for anyone that's wondering, isn't Azure Data Factory just SSIS in the cloud? The answer is no. There is an SSIS integration runtime. You can take your existing SSIS packages, move them into an integration runtime in Azure Data Factory. But Azure Data Factory does so much more. This was actually one of my favorite things to learn more about in the exam prep time. As I mentioned, you're going to have to be able to identify and ingest different data sources. So in the terms of data ingestion, another tool that we have in Azure, separate from Azure Data Factory, which can load data chunks at a time or batching for more streaming data ingestion, we have Stream Analytics. So Stream Analytics is a platform as a service offering that lets you choose different input sources. And those input sources are most commonly things like IoT or Internet of Things devices. IoT, for those of you that aren't familiar with it, is one of the fastest growing data generation segments, right? There are IoT devices everywhere. Manufacturing these days, there's not a manufacturing facility that doesn't have sensors embedded in every single device that they have, telling you how much work it's done in the last minute or hour or day, what the quality of those things were, how fast things are happening. When we think about your vehicle is an IoT device on wheels. All major automotive manufacturers have tons of sensors embedded that track a ton of different data. Think of how computer-driven your car is these days. Even on a personal level, those of us that have Fitbit watches or Garmin watches or anything like that, this is an IoT device right here, right? Tracking my heart rate, tracking my steps, tracking how fast I run, tracking how far I cycle. So IoT is this huge data generator, consistently large volumes coming in all the time. Stream Analytics is a tool that can handle that. Some other data is also generated, not from specific devices, but from applications, right? Think about like medical devices. They may be writing stuff to an application. A web page could be generating data like clickstream data, ad data, that sort of thing. So Stream Analytics also has a feature called Event Hubs that allow you to ingest data from software rather than just from devices. And these are the kinds of things that you need to be familiar with for that Azure Data Engineering certification. And then we get to data analytics. And this is, after they rewrote those exams, I feel that this became a bigger portion of it. Your data analysts and data scientists are going to use tools to query that data, analyze that data, write their models, test them, train them. In Azure, we're hoping that they use Azure Databricks. Azure Databricks allows you to build up a cluster, a distributed system of computers, and then run Spark-based or Apache's in-memory database system, essentially, to query that data. It's very fast. You use, you use notebooks, like Jupyter Notebooks, that's Azure Notebooks, to write these scripts. Python, R, SQL, all of those languages I've talked about are used in Databricks. So there is a focus on this as kind of the end piece of that data engineering piece. Question?
Does Synapse replace any of the functionality of Databricks? Is there some overlap?
That's a great question. Does this Azure Synapse Analytics platform replace Databricks? And I don't have a good answer for that yet, as I don't know about all the analytics capabilities. Yes. All right. So now, who wants to see a little bit of an example of this, right? Because it's most practical when you can see what a data engineer is going to have to do and like what kind of problems you're going to have to know how to solve. So an example, and this is just, this is actually a demo that you can pull off of our GitHub repo and run yourself if you want to play around with this a little bit. One example of a problem we might have to solve is that we work at a call center. We take a lot of calls, and we are trying to identify what fraudulent phone calls are. because that's becoming a big problem in our system, wasting our time, wasting our money. So a data engineer or a data analyst probably is tasked with identifying phone numbers that are generating fraudulent calls. End goal, we can block those from our system. The data engineer in this case is going to be the person that does things like answers these questions. What data do I have? Where is it? How am I going to bring that into my Azure system? Once I have that there, what tool, language, problem solving am I going to do to understand what defines a fraudulent call? Once I've done that and I've sorted that out, how do I take that data and push it into a data store so that we can do actionable things based on it? So the solution, I had built a slide to show the beautiful input of this on the plane on Sunday when I was on my way here, and then I closed my laptop and I didn't save it. And I went to open my slides this morning, and I went, where's my architecture reference guide? So in addition to not having a mouse clicker this morning, I also lost a slide. So I wish I had a whiteboard, but the pieces that we're going to be talking about for this are using Azure Event Hubs to take that incoming source data, using that stream analytics tool that I just talked about to ingest the data, using something like Cosmos DB as a data store, and then I'll show a quick how we can connect that into Power BI to analyze and generate the data. Pre-recorded, so bear with me. I didn't want to risk the wrath of Azure today during my demo. So what we have here to start with, I think I actually have to, okay, there we go. What we are doing here is simply starting with building an event hub. Event hubs start with namespaces. Kind of like if you use SQL database in Azure, you have to build a logical SQL server. Event hubs require an event hub namespace. I'm using a lot of basic defaults. It creates very quickly. Once my event hub namespace, that logical grouping is created, we're going to go ahead and we're going to actually create a specific event hub. So again, this is all being done in Azure to show you what different, in the portal, to show you what different options you have. One of the things that I can show you is how to go into the resource after you've created it and download that resource manager template to do it as code. So now we have an event hub namespace called EHN Telco, and we have an event hub called EH-Telco. So that's pretty simple, right? We've just placed where we're going to be getting our data. Now what we want to do is create the actual event hub and get some more information on it. All right. It's really weird to talk through a demo I did a week and a half ago. So bear with me, this is a little bit awkward. So we have the resource group, we have the throughput units. Give me one moment. I am going to actually switch over to one slide so that I am seeing exactly what you're seeing. Okay. Okay, here we go. That's easier for me. Thank you for bearing with me for a moment. So now in our Event Hub namespace, one of the things that we have to do is get a security token to enable our application. So we're going to have this application generating the phone numbers that are coming in. We have to be able to connect that application to our Event Hub. So we need to get our shared access key. Security is a big part of all of this. It's not something that you can ignore. So you'll see that I'm coming in here and I'm copying a connection string called telco app. So I have my Event Hub namespace, I have my Event Hub, and I have the security piece of it. Yeah, I want to go to the next slide. There we go. Now, just to simulate this, and this is something you'll do if you get the demo, I'm going to go ahead and open up my application. I'm going to modify my configuration file and put in that shared access key. This is kind of that connection string for getting my application to talk to my Event Hub. Now, this is probably something that the application or software engineer would deal with, not the data engineer, but I just wanted to show you how those pieces work together. You'll see I'm changing the Event Hub name to reflect my Event Hub, and then my connection string there that I'm highlighting, where it says endpoint, I'm going to paste in my new primary connection string. So now, I have an Event Hub to ingest the data, and I have my application's connection string updated to speak to that Event Hub. Now I'm going to just kick off my application using the command line, yay, to run the data. And this is, again, simulation is a call center. This is a JSON document in the background that's accepting information like source telephone numbers, how many times they've tried to call, how long the call lasted, that sort of thing. So in the background, my application is merely generating a JSON document and sending it up to an Event Hub. Okay, so the next step here, there we go. We now need something that's going to take this data that's being streamed into the Event Hub and process it, right? This is that data ingestion and data streaming that we talked about. So I'm going to be building a stream analytics job. Stream analytics jobs are essentially you say you have an input of data, so that's going to be the Event Hub. You have an output of data. Again, we're going to choose Cosmos DB, Power BI. And in the middle, you have some sort of transformation that says, we have this giant pile of data coming in. This is the useful information that I want to get out of it. So what I'm doing here is the first step is to add the stream input. You'll notice that my input that I chose was an Event Hub, because this is coming from software rather than an IoT device. Again, most of what I'm doing here is very just default driven, but we've added our stream input, and now the demo takes a minute because it verifies that it can connect, or that it can create that call stream, and now we want to say where we're going to output the data. So we verify our input, or specify our input and specify our output. You'll notice there's lots of options here: SQL database, Cosmos DB, Power BI. We're going to go straight to Power BI so that I can show this in time. This is where I went to do this live last week, and the Azure services weren't talking to each other, much to my frustration, which is why we're getting a pre-recorded demo, because it worked the next day. Again, security, authorization, cloud. So what we're going to have, again, with Stream Analytics, we've defined our input is the data's coming from an application. We've defined that our output's going to be Cosmos DB or Power BI, something to store the data, something to analyze the data. With Stream Analytics, and this is, again, a piece of the Azure Data Engineering and just a piece of data engineering in general, we're going to be looking to answer that question of all the data that's coming in, how much of that do we want coming out, and how do we define that? In Stream Analytics, we're going to be writing a structured query language query. Stream Analytics uses SAQL, so we have T-SQL and we have PL/SQL. This has a variation of SQL, but it is just structured query language. So you'll notice, so I've now selected query over here on the left-hand side. So I've defined my input, I've defined my output, and I've defined my query. And you'll see that down here on the bottom pane, it's showing that live data as it's streamed in. I have a query that is saying, okay, my data set consists of, again, calling numbers, calling identifications, timestamps. What we're looking at here is the where and the group by. This is some of the special stuff in SAQL dealing with streaming data. It's called the tumbling data window that allows us to compare data over time. Essentially what we're saying here, the query that I as the data engineer have built is, I identify a fraudulent call if the same exact number calls X amount of times within a second, because we know then that's like a robocall, a fraudulent call, that sort of thing. To us, a legitimate phone call wouldn't be same number repeated times. That's essentially all I've done with this query. So now, after I've identified my input and identified my output and identified that query in the middle to narrow down my data, I start the actual stream analytics job. And this is something that can be done one time. It's something that can be scheduled. It can be done in a variety of manners. So at this point now, I have this application that's getting all of the phone numbers that are coming into the call center, what number they're coming from, what time they called, how long it's lasted. That's being ingested into an Azure Event Hub, which exists to grab data from IoT devices or apps. It's gone into Stream Analytics then to process the data. And last but not least, I'm going to come into Power BI, and I'm going to create a dashboard that shows this data. I actually have to start that video. There we go. So I create a dashboard. It's very easy to hook a Power BI dashboard into a Stream Analytics job, Power or SQL database, a SQL data warehouse, Cosmos DB. You'll see that I'm going to add just a couple of tiles. You'll see the data source I choose is custom streaming data, which is my Stream Analytics. I choose that data set that I built. So since I authorized that my Stream Analytics could talk to the Power BI service, it automatically sends my data set names over here. I choose to add a tile that simply shows us a current count of fraudulent calls. And the next thing that will show is that it's going to be another, like a line chart of how many fraudulent calls happen over the last 5 minutes, right? So these are tasks. This is a really simplification of tasks that a data engineer would do. And of course, if we were doing true data engineering, we would go and we would get all of the ARM templates out for this. We'd be putting that into our source control. We'd be putting that into our pipelines. But these are things that a data engineer would do. Just a very simple example. So let's go ahead and just finish up then. What I want you to take away from this session. Again, if you find this interesting, we have 3 additional sessions this week. Azure Storage Options for Analytics is this afternoon, and Azure Data Engineer's ETL Toolkit is on Thursday, and Data Modeling Trends for 2019 and Beyond is on Friday. And a couple of our speakers for those are sitting right up here in the front row. Wave. All right. So I would suggest that you study for and take the Microsoft Data Engineer certification exams. Again, we have a workshop going on in room 204 this week to do just that, to enable you to prep.
Question about that room 204, was that a pre-registration kind of thing, or did it drop in?
I don't know off the top of my head, but we can find out. Was it pre-registered? Okay, thank you. Yeah, it wouldn't hurt to probably stop by and ask. Learn comparable tools from other vendors, right? And this is me at Microsoft saying this, but most companies are invested in multiple different things. And again, a lot of developers, even at the same company, will use multiple terms. But you're going to want to be familiar with what other vendors have as other tools so that you can work, again, data engineering is a discipline. It involves multiple different things. Again, I highly suggest you learn Python, right? If there's a language that you want to invest in and learn, This is where I'm going, language of data science. Explore the parts you find most interesting, and also understand this is a long-term process, right? I covered a lot of stuff. People don't go from being a DBA to a data engineer in 6 months. This is something that takes time and investment. So I hope you have a lot of luck with that. My slides have additional resources on them. Thank you for coming. I know we're at time, but again, if you have questions, please feel free to stick around and I'll answer questions for about 5 minutes on stage to allow the next presenter time to get up here. Oh no, it's lunch after this, isn't it? I'll stay up here answering questions as long as you would like me to, but Jess will get hangry at about 12:30. So thank you for coming.